Hello guys, what's up? How you all are doing? Welcome to Mathology Overflow, the second video. Let's get started. Let's move on to our next set of problems. There are 3 plates and 4 balls in a shop. How many ways are there to buy a plate and a ball? So we have 3 plates and 4 balls. Let's say the 3 plates as a category of object type 1 and 4 balls as a category type 2, object 2. We are asked to find the number of ways to buy a plate and a ball. Let's name the plates as P1, P2, P3 and the balls as B1, B2, B3, B4. We are asked to pick any one of the P's and any one of the B's. Stress on end. We can pick P1, B1. We can pick P1, B4. We can pick P2, B3. We can pick P3, B2, etc. Let's try to visualize this in a tree format. The left-hand side over here are the P's and the right-hand side are the B's. Every link between a P and a B is a selection of a plate and a ball. Let's count the number of links. If we select P1, we have 4 possible alternatives for the selection of a ball. So we have 4 links over here. We have 4 links over here. Similarly for P2, we have B1, B2, B3 and B4. We have another 4 links. For P3, we have once again B1, B2, B3, B4. 4 links. In total, there are 12 links. Let's look at it another way. Imagine we have a 3x4 table with rows as P1, P2, P3 and the columns as B1, B2, B3, B4. Each cell in this table represents a selection of a plate and a bowl. So it's easy to see there are 12 cells in total. This cell belongs to a selection of P1 and B1. This one belongs to a selection of P1 and B2. Similarly for this P1, B3, this one P1, B4. This one belongs to P2, B1, P2, B2, P2, B3, P2, B4, P3, B1, P3, B2, P3, B3 and P3, B4. So in total there are 12 cells. Also note that the choice of selecting a plate doesn't influence the choice of selecting a bowl. In the tree that we looked earlier, we could have selected a bowl first and then a plate. Something like this. We could have selected B1 first and then we could have selected P1, P2, P3. We could have selected B2 and then P1, P2, P3. We could have selected P3 and then P1, P2, P3 and finally P1, P2 and P3. So there are 3 links for every B. For every bowl, there are 3 links. For every bowl, there are 3 plates. So in total, there are 12 links. In the table that we saw earlier, we could have had a 4x3 table where the bowls are the rows and the plates as the columns. Every cell over here would represent a selection of a bowl and a plate. So this particular cell would go for B1, B1. This would go for B4, B3. This would go for B2, B2, and so on and so forth. We still have 12 cells. Thus, if an object 1 can be selected in m ways, and object 2 can be selected in n ways, then object 1 and object 2 can be selected in m product n ways. The crucial part over here is the thing and. We have to select object 1 and object 2, both of them. Alright, let's try a different variant of this problem. Now, in addition to the 3 plates and 4 bowls, there are now 6 spoons in the shop. Question is the same. How many ways are there to buy a plate, a spoon, and a bowl? So in addition to the P's and the B's, there are now also S's. So now we have let's visualize this once again, because when you visualize a particular problem, things become much easier or clear in some fashion. So you have a P1. For one P1, you have 4 bowls P1. For one B1, there are 6 spoons S1, S2, S3, S4, S5, S6. So for one P1, there are 6 links. Now, we also have a B2. For a B2, we will have the same 6 choices. For B3, the same 6 choices. And for a B4, we would have the same 6 choices. So in total, we would have 24 links for one plate. And we have 3 plates in total. You could imagine the same being for P2 as well as P3. So 24 multiplied by 3 is 72. You could interchange the order. You could first start off with S and then a B and then a P. Check. You would always find the number of links to be 72. So here we have introduced another object, an object 3, which can be selected in P ways. So first we had an object 1, which could have been selected in M ways, an object 2, which could have been selected in N ways, and now an object 3, which can be selected in P ways. And we need to select an object 1, an object 2, and an object 3. And the number of ways to do that, as we have seen in this tree, is M cross N cross P. Let's look at the next problem. There are 3 flights from Kolkata to London and 6 flights from London to Helsinki. In how many ways one can fly from Kolkata to Helsinki? Let's see how can we solve this problem. Let's denote Kolkata as K, London as L, and Helsinki as H. Let's denote the flights from Kolkata to London as F1, F2, F3. Let's denote the flights from London to Helsinki as G1, G2, G3, all the way up till G6. For a traveler who is flying through F1 from Kolkata to London can select any of the Gs to get to Helsinki. So if we have to draw out the tree, then we could proceed in this fashion. F1 has a link to G1, G2, G3, all the way to G6. Similarly, F2 has a link to G1, to G2, to G6. F3 has a link to G1, to G2, all the way till G6. So for every F, there are 6 Gs. And there are 3 Fs in total. So there are 3 times 6, 18 links. So there are 18 ways one can fly from Kolkata to Helsinki. Think about this fashion. This problem has the same concept of picking up objects from a shop as we did in the previous 2 problems. Let's see if we can add a new variant to this problem. The next problem might be a bit interesting. In addition to the flights from Kolkata to London to Helsinki, 5 flights have been introduced from Kolkata to Zurich and 4 flights from Zurich to Helsinki. How many ways one can fly from Kolkata to Helsinki now? Let's denote Kolkata as K, London as L, Helsinki as H, and Zurich as Z. So these are my 4 cities. There are 3 flights, F1, F2, F3 from Kolkata to London. There are 6 flights from London to Helsinki. There are 5 flights from Kolkata to Zurich. There are 4 flights from Zurich to Helsinki. Let's denote that as N1, N2, N3, and N4. So a passenger has 2 options. Let's write down the options. Option 1 is to fly from Kolkata to Helsinki via London, or option 2, fly from Kolkata to Helsinki via Zurich. Let's try to draw the tree, but before drawing that, please note that we have already solved this problem in the previous question. We have already solved the number of ways one can fly from Kolkata to Helsinki. This was 18. So we need to find the number of ways to fly from Kolkata to Helsinki via Zurich, which is our option 2. Let's draw the tree. So you have, for every M, you have 4 N's. N1, N2, N3, N4. And you have 5 M's. Right? So this becomes, every M has 4 links. So 5 M's would have, in total, 5 times 4, 20 links. So for option 1, there was 18. For option 2, there's 20 ways. But what would be the solution to this problem? Do we multiply 18 times 20? Or do we do something else? Think about it for a couple of seconds. Does the traveler have to go through Zurich and London in order to reach A? Let me say the question again. Does the passenger has to go through Zurich and London in order to reach Helsinki from Kolkata? The answer is no. There's an option. Either he chooses London or his choice is Zurich. Hence, we add the numbers over here. So 18 plus 20 equals to 38. Let's move on to the next problem. So problem 0.8, but now we want to buy 2 objects of different categories. So the categories being a plate, a bowl, and a spoon. So either we buy a plate and a bowl, or we buy a bowl and a spoon, or we buy a plate and a spoon. So we can buy a plate and a bowl in 12 ways, because there are 3 plates, there are 4 bowls and 6 spoons. We can buy a bowl and a spoon in 24 ways, and we can buy a plate and a spoon in 18 ways. So in total, we can either buy a plate or a bowl, or a bowl or a spoon, or a plate and a spoon, and hence we add these 3. That comes to 54. So whenever there is an option to include a group of objects while counting the number of ways, we add them. In short, whenever you see and, think multiplication. Whenever you see or, try to think as addition. Let's move on to the next set of problems. John wants to create an account on a popular online math competitions platform called Mythology, and the password should have 8 characters, which can be English alphabets, both uppercase as well as lowercase, the digits 0 to 9, and 3 special characters. How many such passwords are possible? So, you need to create a password which has certain sets of limitations. You're given 8 characters. Let's first figure out how many choices do we have for the first character. We can have English alphabets, both uppercase and lowercase. So the uppercase and the lowercase are not identical. They are treated as different letters. So A and the capital A and the small a are different. So there are 26 uppercase alphabets, there are 26 lowercase alphabets, there are 10 digits, there are 3 special characters, and in total there are 65 choices for the first character. Now, before moving on to the second character, question yourself, how many choices does the second character have? And does the choice of the first character affect the choice of the second character? Answer to the first question would still be 65, and as a result of that, we could also see that the choice of the first character doesn't affect the choice of the second character. Similarly, for all other remaining characters, there are 65 choices. So we multiply over here, and the answer comes around 65 to the power 8. We have seen a similar sort of problem. I'm talking about 0.7 and 0.8. Let's try to rephrase this problem into what we have seen so far in problem 0.7 and 0.8. We could say there are 65 objects of type 1, 65 objects of type 2, 65 objects of type 3, all the way till 65 objects of type 8. Now the question is, how many ways you can choose an object of every type? So there's an and over here. You need to choose an object of type 1, and you need to choose an object of type 2, and you need to choose an object of type 3, and so on, all the way till an object of type 8. So over here, we can choose the number of ways of choosing object 1, that's 65. Object 2 of type 2 is 65 as well, all the way till 65. That's 65 times 8. There seems to be some sort of a security issue at Mathology HQ. There are some rules now regarding creating a password. The first character has to be a digit. Alright, so the character 1 can only have 10 choices now. The second character has to be an uppercase English alphabet. Alright, so C2 have only 26 choices. The third character has to be a lowercase English alphabet except the letters X. Alright, so C3 now has 26 minus 1, 25 choices. The fourth character can either be a special character or a digit. So the number of special characters are 3 and the number of digits are 10. So in total there are 13 choices for the fourth character. The remaining characters doesn't have any constraints, so 65 choices from there. So what are the total number of ways over here? It's 10 times 26 times 25 times 13 for the first 4 characters, and for the remaining 4 it's the usual 65 times 4. Note that the choice of any character does not impact the choice of any other character. This is a very crucial point that you should take away from this particular slide. So let's summarize the key concepts. If there are m ways to do an operation on object 1 and n ways to do an operation on object 2, the total number of ways to do both and, being the crucial keyword over here, is the product of m and n, m times n. If there are m number of ways to do an operation on object 1 or n ways to do an operation on object 2, the total number of ways to do either of them, or, being the crucial word over here, is the sum of m and n, that's m plus n. We also saw in the previous problems that selecting one object, the choices of selecting one object does not impact the number of ways to select the next or the previous object. Thus, the choices of selection are independent of each other. Please note, this will not be the case always. So you need to figure out, based on the problem, where the choices are independent of each other, where the choices are dependent on each other. We'll look at more dependent choice problems in the future videos. Once again, just to summarize, when you see AND, think about multiplication. When you see OR, think about summation. That's all for this video. We will look at more such key concepts in the upcoming videos. If you like the content, show some love. If you have some suggestions for improvement, please comment down below. Feel free to ask your questions, your doubts. Please like and share the video with your friends. Subscribe to this channel and stay tuned for the next one.